Alright, so for this question, question number 5 by A. Alright, so we want to check for first, we're given this function of gx, right, defined by two functions, two part. Okay, gx is equals to 3 when x is in between 2 and 8. Okay, and then this absolute value of 8 minus x over x minus 8 plus k when x is greater than 8. Okay, so now we need to find this value for k such that gx is discontinuous at x equals to 8. Alright, so this is what we are given over here is the case where it is discontinuous at x equals to 8. So we understand that if it is continuous, the first the rules that we need to follow is g of 3 is equals to the limit for x approaching, g of 8 over here. So the function of g when x is equals to 8 is equals to the limit of x approaching 8 for gx. So this is when it is continuous. So now we are looking for when it is discontinuous. So if it is discontinuous, meaning that now the equation that we are looking for is g of 8 is not equals to the limit of x approaching 8, okay, for gx. Alright, so in this case we only have we only have two different functions, two different parts, right? So for g of 8, this also meaning this is also the same value as x approaching 8 from the left. Okay, so this one x approaching 8 from the left. Alright, so for this one on the right hand side, we will take this one as x approaching 8 from the right hand side so that we can use the second part of gx over here. Okay, so for the function when g of 8, okay, the value is equals to 3 over here. So if this is equals to 3, okay, we want to check for, so this side we will use this function, okay, limit x approaching 8 from the right. So this is the function that we are looking for, 8 minus x and then x minus 8 plus k over here. Okay, so when we have it like this, so what we're gonna do next is, okay, this left hand side will just stay the same. So pretty much we will operate with the value for the right hand side. Okay, so we will have over here limit of x approaching 8 from the right. Okay, so if it is from the right over here, we can change that to negative. Alright, and then we have 8 minus, okay, so if you put 8 minus x over here, okay, so we will take the negative value, right, and then this one is divided by x minus 8, okay, and then we have this plus k over here. Okay, so the next line that we have is x is 3 is not equals to, so if we substitute this, if we rearrange this value, we will have over here, okay, so if we double check here, we will get that. Okay, so kalau if we factor out negative x over here, okay, we can simplify this so that this will just become 1 plus k. Okay, so if you look at this one, you factor out again negative. Okay, this one, the first one, we factor out negative from this absolute value function over here. Okay, and now if we factor out negative again, so that you will get, okay, negative of negative again. Okay, so that will be a positive actually. How do I write this? So that will just be a positive of x minus 8 over here, and then we divide by x minus 8, okay, plus k. So I factor out again negative over here. Right, so we are now just left with the limit of x approaching 8 from the right. This will just be 1 if we simplify this. So we have 1 plus k. Right, so if you look at this function that we are left with over here, now we don't have any more term of x, so that is just gonna be 3 is not equals to 1 plus k. Alright, and if we rearrange this, k is not equals to 2 over here. Alright, so this is the value of k, values of k. So k can take all values except for 2 because it is discontinuous at x equals to 8. Right, so this is for question 5 part A. Now, if we look at question part B, so we want to determine whether fx is continuous at x equals to 3. So if you still remember, we have three conditions for continuity. First, you have to check f of x must be, let's say the continuity we want to check is at c. Okay, so f of c must be defined. Okay, that is the first condition. Okay, and then the second one, okay, so the limit of fx, okay, when x approaching c from the left must be equals to the limit of x approaching c from the right of fx. Okay, so this must be equal so that exists, so that the limit of x approaching c of fx exists. Okay, and then the third one, the third condition that it must satisfy is f of c must have the same value with the limit of x approaching c for fx. Okay, so these three conditions that we need to check. So let's check this one by one for the continuity of fx at x equals to 3. Alright, so part 1 over here, we need to check that it is defined. Okay, so f of c is defined. So f of 3, f at 3 is defined. So f of 3 is this part, the second part of fx. So that is equals to negative 6 over here. Okay, so this one is equals to negative 6. And then the second condition, right, we will check this one if limit of f of x when x approaching c exists. So we will check the limit from both sides. Okay, x approaching 3 from the left of fx. Okay, and then we will check from the right. So from the left of fx, that is this first function. So we will have limit of x approaching 3 from the left, and our function is 9 minus x square over here, and then divided by x minus 3. Okay, so we can actually factor this out. So we will have 3 minus x over here. Okay, and then we will have 3 plus x. Alright, and that is divided by x minus 3. Okay, to simplify this further, we can actually factor out the negative sign so that we can simplify. Okay, so we factor out negative. This will be left with 3 plus x. Okay, so we can simplify this 3 minus x with x minus 3 down here by factorizing negative over here. Okay, then we will get this value if we substitute with 3. So we will get that this will be negative 6 over here. Okay, so we check the second condition. So limit for x approaching 3 from the right of fx. Okay, and that function is given by limit of x approaching 3 from the right, and this function is the last function down here. So we have 162x, right, minus 54x square, and then divided by x cubed minus 27. Okay, so to simplify this, okay, we can see that we can actually factor out 54 from the numerator. So we will get x approaching 3 from the right. Factor out 54, we will get over here 162 divided by 54. Okay, actually we can factor out 54x over here. Okay, so 54x, alright, then we will have over here 3 minus x. Right, and then for the denominator, we can also factor this, as in factorizing this, we can get x minus 3. Okay, and then over here we will have x squared plus 3x plus 9. Okay, so you have to factor out the cubic function down here on the denominator. So now we will have that limit of x approaching 3 from the right So over here, to simplify 3 minus x and x minus 3, okay, so to simplify these two terms, you actually need the negative sign, right? So this one and this one, you have to factor out the negative sign first for the numerator. So you will get negative 54 x over here, okay, negative 54x for the numerator, right? So having this, now for the denominator, we will have that is equals to x squared plus 3x plus 9. Okay, so we have already simplified, and you need to add the negative sign. You factorize out negative first so that we can simplify 3 minus x with x minus 3. Okay, and then after that we can do direct substitution over here, and if we substitute 3 over here, you will get negative 6 also. Okay, so substitute 3, you will get negative 6. And then finally, you can check that, okay, we now have, okay, let me just separate this first. Okay, so now we already have that for the second condition, we have the limit of x approaching 3 from the left of fx, right, is equals to the limit of x approaching 3 from the right of fx, which is equals to negative 6. Okay, and then we can say that the limit of x approaching 3 of fx is equals to negative 6. Okay, and then for the third condition, alright, the third condition over here, we have that we can already check that f of 3 is actually equals to the limit of x approaching 3 of fx, okay, and that is equals to negative 6. Okay, so we can say that therefore fx is, okay, so we can see that it is continuous, okay, at x is equals to 3. Okay, so this is our final answer and the solution for question number 5 part B. Okay, so always remember these three conditions, and then we will just check the continuity by following the three conditions. Right, so this is satisfied, it is continuous.